Hello students, myself Mrs. Dipali Nehate. I am working in Deccan Education Society's Fergusson College. I am teaching Vocational Computer Science subject paper 1. Today's my topic is data structure. So what is that data structure? How data is stored in the memory? Which type of structures are there? That we will see by using the PowerPoint presentation. Topics we are going to see in that are introduction of the data structure, then data structure operations, algorithmic notations and control structures, array representation in memory, then various operations on the data structure like traversing, deleting, sorting, binary search, linear search. Then next one data structure is a pointer arrays, records, representation of records in memory, linked list, representation of linked list in memory, tree, binary tree, representing binary tree in memory. Introduction of data structure, that is what is the data, group elements and elementary elements, what is difference between that two, then what is entity, what is field, record, file, and what is the data structure and its type. This topic we are going to study in today's lecture. So first, values or set of values. Then the data is bifurcated in two types, group items and elementary items. So group items are which are divided into the sub items are called as the group items. Then for example, date, it is divided into the three sub items like day, month and year. So date becomes a group item. Elementary item which is not divided into the sub items are called as the elementary items. Like pin code, it is not divided into the sub items, so it is called as the elementary items. Next term is entity. It is very important. Entity is the something that has certain attributes or properties. So student is an entity, then table is an entity. The thing which you can represent, it is called as the entity. The values themselves may be numeric or non-numeric. So to represent that entity, for example, student has roll number, name and address. So name, roll number and address are the attributes of that entity, and they are storing values. So these values may be numeric or non-numeric. A biodata mainly contains the fields like name, age, gender and education. So name, age, gender and education are called as the properties of that entity. Then name can store value ABC, age store value 23, gender store value F, and education, it is MSc Computer Science. So these are the values which are numeric and non-numeric. Next term is field. So what is a field? Field is a single elementary unit of information. It represents the attribute of entity. So in the previous example, name, age, then gender, education, these are called as the fields. Record is a collection of fields of values of the given entity. So collection of, in the previous example, name, age, then gender, these are called as the records of that particular entity. Then file, it is a complete collection of records of entities in the given entity set. So file contains the group of records. So you can store their records of 5 students, then you can create its file. Next, in this example, serial number, name, address and telephone number, these are the fields, and serial number can store two values, 1 and 2. Name store two values ABC, XYZ. So collection of that all the fields is called as the records, and single elementary unit, it is called as the fields. So these are the attributes, serial number, name, address, phone number, and it stores their various values. And group of these values is called as the records, and single elementary unit is called as the field. Next, what is the data structure? Last year we learned that first data structure, which is an array. So array is a definition of array is that it stores their homogeneous data in the sequential order. So how that data is stored in the memory, which type of structure it is used, it is called as the data structure. There are basically two types of structure, linear structure and non-linear structure. So array, it is a linear data structure. We'll see first of all what is the definition of data structure. Data structure is the way in which different elements are logically related. Data may be organized in many different ways. And other definition of data structure is collection of data elements forming an organization characterized by accessing function is called as the data structure. So according to the type of data, which type of structure you are going to use, it is called as the data structure. When you want to store their homogeneous data, then you can use their array type of structure. And when the data it contains their numeric and non-numeric values, then you can use their structure like that records. Okay, that we will see in our next syllabus. Data structure should show relationship between the elements. As we know, array elements, first element is stored at location 1000, and if array stores all the character values, then first element's address is 1000, the next element will be stored at location 1001. Suppose the data is integer type, then first element is stored at location 1000, the next element is stored at location 1002. So that data structure should show relationship between that elements. Then types of data structures are linear data structure and non-linear data structure. So linear data structure contains their array, linked list, stack and queue. So which structures are the linear data structure? In this type, elements are stored in the consecutive memory location, whereas in the non-linear data structure, data is stored, there is non-linear, means a linear order, it is not maintained. So non-linear data structure is the linear order cannot be maintained between the data elements. So that's why tree and graph are called as the non-linear data structure. Classification of data structure. The data structure is classified linear structure and non-linear data structure. Linear data structure contains their array, linked list, stack and queue, whereas non-linear data structure contains their graph and tree. This is the tree diagram of the data structure. Then operations you can perform on the data structures are, you can perform their 6 type of operations. First one is the traversing. Traversing means what? Accessing each element at least one. So definition of traversing operation is accessing each record exactly once so that it can be processed. So for example, you are going to perform their printing element process. So print each element of an array. So it is called as the traversing. If you are multiplying every element in the array by 5, then it is also called as the traversing operation. Second operation is the inserting. When you are going to insert the new record in the previous array, then it is called as the insertion operation. So adding new record to the existing structure, it is called as the inserting. Next operation is the deleting. So removing a record from the existing structure is called as the deleting operation. Next, fourth operation you can perform, that is searching. Definition of searching is finding location of a record with a given key value or finding location of all the records which satisfy one or more condition. This operation is called as the searching. There are 2 types of search, linear search and binary search, that we will see in our syllabus. Next operation is a sorting. So arranging the records in some logical order is called as the sorting. You are going to learn their bubble sort. Then merging is the last operation. Merging means combining the records in 2 different sorted files, and you can create their single file. So combining 2 arrays and create a single array, it is called as the merging operation. This question is very important and it is asked for 3 marks. So question is like that, explain the data structure operations. 6 data structure operations. So you have to mention all the 6 operations and you have to give their definition. Next is the algorithmic notation. So what is the algorithm? Then what are the control structures are used to write an algorithm, and what are the types of control structure? That algorithm are divided into they are using their sequential logic, selection logic and iterative logic. First we will see definition of algorithm. So algorithm is defined as it is a finite step-by-step list of well-defined instruction for solving a particular problem. Suppose a problem is to find out marks are provided and the student is pass or fail. Then you will apply their condition. the condition is that the marks are above 35, then you can declare that student as a pass, otherwise that student is fail. So here we are going to use their step-by-step list of well-defined instruction for solving a particular problem. This is the definition of the algorithm. Other one is the other important point while writing algorithm is that data structure affects the design of both structural and functional aspect of a program. So suppose elements are more than, means suppose there are in the definition it is given that find out addition of 5 array elements. Then which type of structure you are going to use, it affects the design of both structural and functional aspect of a program. According to that, you have to write the steps of algorithm. Means what? According to that you have to write their logic, and we will going to use their iterative logic. So while you are writing that algorithm, so data structure affects the design of structural and functional aspect of a program. Next one, while you are writing that algorithm, it consists there two parts. First part is called as the paragraph part. It tells that purpose of the algorithm, and in this part we have to define their variables in the algorithm and list the input data. So this is called as the initialization part and declaration part. And in the second part of the algorithm, it consists of steps in the algorithm. That is, what is your actual logic you are going to use to solve that particular definition, that you have to mention in the second part. So first part is the initialization and declaration part, and second part contains the actual steps of the algorithm. Next, control structures. So there are three types of control structures are used while writing algorithm. First is the sequential logic, second one is the selection logic, and third one is the iterative logic. We will see it one by one. First is the sequential logic. Sequential logic means what? While you are writing algorithm, then it contains the steps, and the second step is depend on the first one. So it follows the sequence. So module execute sequentially one after another. Second point is that the sequence may be present explicitly by means of numbered steps or by order in which the modules are written. So here sequence is important while you are writing definition by using their sequential logic. You can see this flow chart, and here there are three modules. So module, while you will write module A, then depending and you are solving that module A, then control will go for the module B. Then after executing that module B, control will transfer to the module C. So steps are important in the sequential logic. Second is the selection logic. Selection logic is divided into the three parts. First is the single alternative, second double alternative, and third one is the multiple alternative. So single alternative, this is the syntax. First of all, you have to write the condition, but if this condition is true, then and then it go for the module A. Otherwise, control will transfer to the next statement of the after that if structure. There is no else part in the single alternative. That is very important point. So if condition is true, then module A, which consists of number of statement and that are the executed if only that condition is true. Otherwise, module A is skipped and next statement of the algorithm is executed. These are the important point for the single alternative statements. Second one, this is the flowchart for the sequential logic. Here, if this condition is true, then and then it go for the module A. Otherwise, it will skip that module A and go for the next statement after that module A. In double alternative, there is the else part. So you have to write the condition, and if this particular condition is true, then module A will be executed. Otherwise, it go for the module B because there is the else part. So according to the condition, it will decide that whether module A should be executed or module B should be executed. You can see in the flow chart here, if this condition is true, then execute module A, otherwise go for module B. And then control will transfer to the next statement after that module. In the multiple alternative, there are more than one conditions. So here, if condition 1 is true, then execute that module A1, otherwise go for the condition 2. And then If this condition is false, then and then it go for the condition 2. If this second condition is also false, then it go for the condition n, like that, and then it execute that module an. If all these above conditions are false, then go for the else part, and then it will execute that module b. Last year we discussed the program. In that we have to find out grade of a student. So percentage marks are provided. According to that marks, we are giving the grade for the student, like that, A1, then A grade, then B1, then B grade, like that. Or if all the conditions are false, then student will be declared as a false. Here, so the logic of this structure allows only one module to be executed. The module following the condition which is satisfied, and it will be executed. So that condition, only that condition will decide which particular module should be executed. And if no condition is satisfied, then module which is follows that else statement, it will be executed. You can see this is the flow chart for that multiple alternative statements. Here various conditions are there, and which condition is matching, according to that particular module will be executed. Otherwise go for the module B. Iterative logic. Third type is iterative logic. So in that there are two types of structures, repeat for and repeat while. While we will write our algorithm, we will use most of the time this repeat for. So in repeat for, syntax is repeat for k is equal to r to s by t. Then till this condition is true, that number of times that module will be executed. Then end of for loop. So here certain module is executed repeatedly until the condition is satisfied. So here this k is equal to r, this is called as the initialization part. Then k will be increased till the value of s. So this is the conditional part, and how many times by how much value that k should be increased, it is decided by that value t. Okay. So here at first the body of the loop, that is module, will be executed with k is equal to r. So this is the initial value, and then with k is equal to r plus t, that is then with k is equal to r plus 2t. So here you can see that increment is by 1. First increment is with k is equal to r plus t, then k is equal to r plus 2t, and so on. So how much till what value that k will be increased? Till s. So when that k is equal to s, at that time that execution of that loop will be stopped. The loop ends when k is greater than s. So this is the when this condition will be false, at that time loop stop its execution. Okay. This is the flow chart of this repeat for structure. Here you can see this is the initialization part. This is condition. So k is initialized, k condition, k is greater than s. Till this, if this condition is false, then execute that module and increase value of k, and when that k greater than s, this condition will be true, then it go for the next statement. So this condition will be decide how many times that loop should be executed. Next structure is repeat while. So in repeat while, the syntax is repeat while, and you have to specify their condition, and till that condition is true, then this module will be executed. Then in bracket specify the end of the loop. Here body of the loop, that is module is executed repeatedly until the condition is satisfied. There must be a statement before the structure that initialize the condition controlling loop counter. So here before starting this loop, there should be the initialization statement. So here initialization part, then condition part, and between that module you must have to write their increment statement. Okay. While in the previous structure repeat for, all the initialization, condition and updation counter part within the same line. Here it is divided into the three part. First of all, here you should have to write their initialization, then write their condition, and here that module statement, After that, here there is the update counter. Okay, so there must be a statement before the structure that initialize the condition controlling loop counter. Then, and one statement which change the value, which is called as the condition counter. This is the flowchart of the repeat while structure. Okay, so here there is the initialization, condition, module, and update counter statement is there. So there, these are the three types of logic are used while you are writing their algorithm. Then next, first data structure we are going to learn, that is the array. So definition of array is, what is a linear array? Linear array is the data structure which consists of finite ordered set of homogeneous data elements such that the element of the array are referenced respectively by an index set that is called as the subscript consisting of n consecutive numbers. First important point is array stores their homogeneous data. Then array elements are referenced by the index number consisting of n consecutive numbers. So you can store their n values in that array, and array it is a linear array. So it is the linear data structure. The elements of the array are stored respectively in the successive memory location. So this is the linear data structure. Array is a linear data structure. Why? Because all the elements are stored in the sequential order. The number n of the element is called as the length or size of the array. Here the length can be found out by using this formula. Length is equal to ub minus lb plus 1, where ub is the upper bound, lb is the lower bound, and subtraction of ub minus lb plus 1, it gives you the length of the array. That is how much elements are stored in the array. Okay, so the length can be obtained from the index set by using this formula. Consider this linear array data. It stores their 5 elements, and these are the index numbers. So the elements of the array may be denoted by the subscript notation such that data of 3 is equal to 400. Suppose I want to access the particular data which is stored at location 3. So I can access by data, then in a square bracket I must have to mention that index number and then is equal to that value. So I will refer the element and then I can access that particular element. So length of the array is, you can find out that here ub means upper bound of the array is 4, lb is 0 plus 1. It means that this particular array data store their 5 element. You can see how can I find out it. Then how you can represent that array in the memory. So elements are stored in the consecutive memory location. So just require their first element's address. According to the data type, the next element means suppose array store their integer values, then each and every element will take their 2 bytes. If array is of type float, then every element take their 4 bytes. So where the next element is stored, it is decided by the data type of the array. So to traverse that array, you just require the array first element's address. Then this is called as the base of LA. Using this base address, computer calculate the address of the any element. I told you the data type is very important to find out that next element's address. So that data type, that is the number of bytes they are stored by using that value W. So this is the formula to find out location of any element of the array. So formula is LOC in bracket LA of K is equal to base of LA plus W into K minus LB. So base of LA, it stores the address of the first element. W is the required number of bytes to store that single element. K is the index number and LB is the lower bound. So LOC of LA of K is the address of the kth element of LA, and W is the number of words. Words means number of bytes per memory location for LA, and LB is the lower bound, that is the smallest index. Here consider this following diagram. array name is LA, and first element is stored at location 1000. These are the 1000, 1001. These are the memory locations. And then this LA of 1, this is the base of LA, first element's address. And these all the elements are stored in the sequential order. So you can find out that particular element's address when you are knowing that all the values. So here base of LA is 1000. To store that single element, it requires there 1 byte of memory. So value of W is 1. Okay. So by using this previous formula, you can find out that what is the particular element's address. This is the algorithm where we can find out the largest element in the array. So for example, name of the array is data. It stores these 5 elements, 10, 20, 40, 35 and 15. These are the index number of all these 5 elements. I told you while you will write the algorithm, 2 important parts are there. First is the initialization part and second is the actual logic you are going to use. So here first of all mention what are the required value you require for the to solve that particular definition. So largest, and in square bracket data is the array name, n is the number of element, and max is the variable which stores that maximum element from the given array. So this is the initialization part. You have to explain all these terms in the paragraph part. So data is a linear array with the n elements, and this algorithm find out the largest element max of data. Here steps to solve that algorithm. In the step 1, initialize that counter. So k is the counter which initialize value 1. Then max is equal to, max should be initialized with the data of 1. What is the logic we are going to use here? We will compare that first element with the second. If first element is greater than the second one, then we will store that second value in the max variable. So this is the initialization part in the step 1. Here you can see that k is equal to 1, max is equal to data of 1, and therefore max is equal to 10 because data of 1 store value 10 and n is equal to 5. So compare and update. Here this is the important logic to solve that particular definition. In comparison, you have to compare each time value which is stored in variable max with the data of k plus 1. Initially data of k is 1. So that's why it is accessing value 10. So if value in the max is, suppose it is less than that data of k plus 1, then you should have to update that value of max variable. So here in this is called as the analysis chart, and according to this logic, I designed this chart. First comparison between the element 10 and 20. This condition is true, then change value of max variable and update counter for going to the second iteration. Then test that counter whether that counter is less than 5, that is the maximum value. Then go for the next value. So therefore next comparison between the 20 and 40. So condition is true. So therefore update variable max, update counter, go for the next value. So here max variable store value 40. That 40 is compared with the next value, that is 35. So condition is false. So there is no updation of the variable max. Go for the next value. Then compare value of max with the last value, that is the data of 5. So this here you can see that condition is false. And then update counter. Counter is 5 less than 5. This condition is false. So that's why here loop will be stop its execution. Then you should have to specify the value which is stored in the variable max. So students, what we discussed in today's lecture, we discussed the definition of data, then 3 important terms: file, field and record. Then we discuss about what are the types of data structure. Then algorithm. While you will write algorithm, 3 types of logic which are used: sequential logic, conditional logic and iterative logic. And after learning these all the logic, we discuss one algorithm. That is how you can find out that largest element from the array. Okay, next topic we will see in the next lecture. Thank you.